Okay. Residuals. It's all statistics. Chapter 3 is the third of the 3 chapters on statistics. Probably read somewhere in your textbook that you're calculating something called the least squares regression line. Now, you don't have to, all you need to know is why do they call it that, and what it's got to do with residuals, which I will do now. What I wanted to make clear is why it's called the least squares regression line and why residuals are important in calculating it. So I've got on the board there a graph, probably the one we've seen before. I'm not sure whether that's the one about cars and their age. How do you know where to actually draw the line? Now, we had a lesson the other day where you drew it by putting in the equation, knowing the equation and the intercept. Yeah, so that's how you know where to draw it. But how does the calculator know where to get that equation from? How does the calculator know that there's one equation rather than another that is the best fit? What it does is it looks at all the data points, which are blue on here, and it calculates what they call the least squares. And that is the vertical distance, if I can draw it on here, it's the vertical distance from each point to the line. So I'm just drawing those little vertical distances in now. There's an easier one to see. There's another one, there's another one. They calculate all these vertical distances. This is a process that we're going to ask you to do on your assignment as well. So if you can see, I've drawn in some red lines on there. Some of them are above the line, some of them are below the line. Now what the calculator does is it takes all those distances, makes them all positive, so whether it's +3 or -3, they become 3, squares all the numbers, and tries to find an equation which reduces the sum of those squares to the minimum amount. That is basically what the calculator is doing, not mathematically, but in words, that's what it's doing. So it looks at all the distances. In other words, it doesn't know where the line is yet, so it must be doing something clever like working backwards and forwards until it's got the right numbers. But in the end, it has kept to a minimum sum of all the distances from each of the points. Now, you don't need to know much more than that at this stage. There's no real questions coming up except so that you understand where it's coming from. But you will need to do some work with residuals. And there's a better diagram. So you can see all the residuals on there. A residual is the vertical distance from a point to the regression line, and the idea is to minimize the sum of the squares of the residual. If you're interested in taking this subject further at any time, that might be worth having written down as a note. Bearing in mind it only works if the data is linear. If the dots are not linear, then it doesn't work, and it doesn't work if there's outliers either. So linear regression only works under those circumstances, and you'll probably have to reproduce that fact when you do your assignment. All right, so there's a bit too much talk here and not much to do on that exercise except here. So having heard what I've just said, can you tell me what a residual is? Residual is the distance from a point to the line, vertically. So that's what you would write there. The distance vertically between a point and the line of best fit. So if you're doing that question, that's what a residual. We need to know this because when you do your assignment, you're going to be measuring your residuals and comparing them with what the computer's got for the residuals. And if you've done your line perfectly, all the answers will be the same. If you've drawn your line not quite in the right place, you'll find out by seeing that the residuals are different. And the next question in the exercise there's only 3 questions, they all take a few minutes, that's all. Which one of these options have I just said? Do we minimize the residuals? Do we minimize the sum of them? Do we minimize the sum of the squares of them? It's that one, isn't it? You square them and add up. Well done. It's number C. It's not minimizing it, the square of the sum. It's minimizing the sum of the squares of the residuals. And we square them because otherwise you'd have some positive and some negative, and we finish up with an answer of 0 if you added them all up. If you add 3 and -3, you get 0. If you add 9 and 9, you get 18. So you want to get that number and all the other numbers down as small as possible. Right, the 3 assumptions we make about the association. Well, it's got to be linear. No outliers. So numerical data, linear, pattern, and no outliers. Otherwise, it just doesn't work. Okay, are you happy with 3a? That's 3a done and dusted. So I'm going to quickly, 3b looks complicated, determining the equation. Can you calculate the equation of the least squares line? But in fact, I've already taught it. Right at the beginning of this course, or near the beginning, I said, you don't need this yet, but if you go into your calculator and go stat calc linreg 4, and then vars and y vars and all the rest of it, you will get all the information. And that's what 3b is all about. So in 3b, it tells you what to do. Well, here it is again, if you want it. Stat calc 4 on reg-EQ, press vars y vars 1. I'll put this back up on the screen in a minute. And then it'll draw the line and also the scatter plot and also the line. But in exercise 3b, you don't actually do just that. What they want you to do is put the set of numbers, this is question 2, you put these numbers into your calculator and just check that you get the answer down here. Just check you get the answer. So 3b is asking you to do something that you should already know how to do, is what I'm saying. The relationship between gradients and correlation coefficient. Can you remember what the correlation coefficient is? It's not r squared, it is r. And remember, when r was positive, the gradient was positive, and when r is negative, the gradient is negative. So that's all they're asking you there. The slope, the gradient, is found to be negative. What's the correlation coefficient? It's negative. So it's just understanding here. I don't know why they call it big ideas. What about if the correlation coefficient was 0? What would that tell you about the line? The horizontal line. Well done. Horizontal line would have a coefficient of 0. And don't muddle that up with r squared. So, okay, we've done 3a. Work through 3b as well. And on whenever we have maths next Friday, we can do 3c.